Okay, before you watch this video, let me remind you that you need to stop the video and try the problems on your own first. Okay, so stop this video, work through the problems, and then you're going to watch this video and check your answers. If you want to skip through the video just to get to the answers to see if you did them right, that's fine, and then you don't have to listen to my explanation unless you got it wrong, and you need to listen to my explanation. Okay, so do not continue unless you've tried these problems on your own first. All right, we are going to graph y equals 1/2 to the x minus 1 plus 2. Isn't this exactly the same problem that we just did? I feel like this looks really familiar. It is. This is exactly the same as number 5. So anyway, we'll just do it again. Sorry about that. So transformations. This is going to move right 1 and up 2. So we're going to take that point 0, 1 and move it right 1 and up 2. There it is. We're going to take our asymptote, which was y equals 0. We're going to move it up 2. So our new asymptote is y equals 2. And remember, this is a decay function. So it's going to look like this. Our domain is all real numbers, and our range is greater than 2. Our end behavior, which we didn't have before, but we can put it on here. Our left-hand end behavior is that we're approaching infinity. Okay, so because to the left it's going up. Hey, there's the bell. Our right-hand end behavior is approaching 2. Okay. All right, let's check out number 9. A new SUV costs $20,000 and depreciates, means it's losing value, each year by a factor of 15%. So we want to write a function giving the value of this after t years. So this is our A, our initial value, so 20,000. Then we have 1 minus the rate of decay, which is 0.15 to the t. We can do the subtraction in there, so we can rewrite this as 20,000 times 0.85 to the t. All right, we want to know what is the SUV going to be worth after 20 years. If you keep this thing around for a long time. So we're just going to take this and plug in 20 for t and get that into your calculator. Since we're dealing with money, go ahead and round to the nearest cent. So after 20 years, we're looking at $775.19. Now, obviously this is not exact because it depends on what condition the SUV is in and how many miles it has, but this is just a general rule. Cars lose value each year you own them. So don't take too much stock in this, but it's a good example. All right, the attendance for a basketball team declined at a rate of 5% per game throughout a losing season. Okay, we have declining attendance, so this is decay, and they're losing, so people don't want to come watch them. The attendance at the first home game was 23,000 people, 500 people. We're assuming this is a professional team because nobody comes to that. Not that many people come to the Bryan games. How many people attended the 15th and final home game? All right, so let's write our function first. We started with 23,500. 1 minus 0.05 to the t, which we can rewrite that as 23,500.95 to the t. So that's our function that we want to evaluate. How many people attended the 15th game? We're going to plug in 15 right here for t. And we'll just put that into our calculator. Now, this time we're talking about attendance, so we're talking about people, so round your answer to the nearest person. So 10,887 people. All right, last one. The function p of x equals 2.28 times 0.9 to the x can be used to model the number of payphones in millions, X years since 1999. There used to be like payphones around. I know it's weird to think about, but then when cell phones came more and more popular, we don't need payphones. So is this exponential growth or decay? So is the number of payphones growing or decreasing? Well, it's definitely decaying. How do we know that based on our model? It's right here, this number. Because our rate, our base, is less than 1. It's between 1 and 0. Remember, that was what we said would indicate that we have decay, is if that base number is between 0 and 1, which it is, 0.9. Then we want to know how many payphones will there be, there's the bell again, by the year 2020, so next year. So we're going to take 2.28 times 0.9 to the, let's see, in the year 2020, remember this is since the year 1999, so that's actually 21 years. So we're going to plug in 21 and get that all in your calculator, and 0.25 million. Or if you want to write that not with decimals, it's like 250,000, right? So either way is fine. So this is exponential decay. Hopefully that all made sense. And we'll be doing some more activities with decay in class.